There's an old saying or cliche or however you want to put it, measure twice, cut once. And anybody who's done any carpentry work or do-it-yourself work or anything, we've been there. You know, you look at it and you say, oh, I don't need to measure that. I can eyeball that. You know, you do the cutting and then all of a sudden it's like, hey, I should have measured that instead of eyeballing that. Well, the same goes for your subnetting scheme. Whether you come up with it, whether a coworker comes up with it, you should always double and triple check the number of valid subnets available in your subnetting scheme before you start assigning the addresses. Because if you make a mistake and then you got to go back and start reassigning addresses, it just gets to be a mess, and of course it's unnecessary work. You can save yourself a lot of heartache in the real world by going off by yourself for a few minutes and checking your scheme out before you start configuring it. Now, this is a valuable skill to have, period. First off, we've got to be able to come up with the number of valid subnets for the exam. We know that's going to happen, but you got to come up with it in the real world as well. And the thing is, sometimes you do the subnetting and sometimes someone else has done it. And really, your exam questions for the most part are likely going to take the form of, you know, someone else has already done the subnetting, what do you think? And that's exactly what we're going to look at here, because we're going to be presented with the subnetted network. We're not actually doing the subnetting, it's already been done. And it's, by the way, Chris, or fill in your first name, how many valid subnets do I have here? Well, with practice, and I know there's that phrase again, but with practice, you'll answer valid subnet questions on your exams and in real-world networking situations in less than a minute. And I'm going to show you the longer way first because I want you to see exactly what's going on a bit-by-bit level. And then I don't even want to call it a shortcut because it's really not a shortcut. It's more of an accelerated way to get to the correct answer when we're trying to save a few seconds here and there. So we're going to start our practice with these sample questions. I actually have two for you. How many valid subnets exist on the 10.0.0.0.255.240.0.0 network? Second question, how many valid subnets are there on the 10.0.0.0/12 network? And some of you, depending on whether you watch this before or after the RIP section, might be saying, what's that slash thing he's talking about? Well, these two questions are referring to the exact same subnet. They're just using different formats of expressing the subnet mask. Now, the first one used a dotted decimal mask, and that's the 255.240.0.0 that you see there. And the /12, this is what we call prefix notation. And you're much more likely to see prefix notation than a dotted decimal mask in real-world networking and real-world network maps. On your exam, I expect you to see both. And one reason that you'll see prefix notation more often than writing out the full mask on networking maps is actually the visibility of it right in front of you. You know, if I were trying to cram in dotted decimal maps just to my diagrams here in this course, I mean, it would just make them, you know, really hard to read. And then instead you got a /12. It's like, oh, okay, I know what he's talking about. So again, on your exam, I expect you to see both, but you should know that the /12 is prefix notation. And let me show you exactly how we arrive at that, because with prefix notation, the number behind the slash is the number of consecutive ones at the beginning of the mask. That's all it is. And the dotted decimal, 255.240.0.0, that dotted decimal mask converts to the binary string in front of you now. And you can see it's 12 ones at the beginning, and then everything else is a 0. That's where the /12 comes in. Beyond making it easier to read network diagrams and network study guides and that kind of thing, it's a lot easier to discuss the mask verbally. And not that you'll be doing a ton of this, but you'll be doing some of it, and depends on, you know, what your role is in your network support. There's nothing like listening to somebody give a presentation on networking addresses that we're going to use. Instead of saying /30 about 500 times in a meeting, they say 255, 255, 255, 252. Not that I ever sat through a meeting like that once, but it's a lot easier to say and to write. So prefix notation is really preferred in the real world, but again, on the exams, we have to be ready for both. Hey, remember these? These are your Class A, B, and C network masks and your ranges. And I told you they'd come in handy one day. It's not just something you got to memorize. Well, this chapter is that day. And here's a quick review of them. Class A, first octet is 1 through 126, and the network mask is 255.0.0.0, or in prefix notation, /8. Class B, that first octet range is 128 through 191. The network mask is /16, and Class C, that first octet range 192 through 223, and the network mask being a /24, or of course 255, 255, 255, 0. See, it is a lot easier to say /24. So why am I bringing these up right now? There's got to be a reason. Well, these network masks tell us how many network bits and host bits are present. Ones are network bits and zeros are host bits. Notice I'm not saying anything about subnet bits yet because no subnetting has been done. These are the network masks. And the Class A mask, 8 network bits and 24 host bits. Again, the network bits are set to 1, host bits are set to 0. Class B gives us 16 network bits and 16 host bits. Class C, 24 network bits and 8 host bits. So we've broken these down like crazy, right? I mean, we got the ranges down, we got the network masks down, we got this down about how many network bits and host bits are in each one, and there's got to be a reason Chris keeps bringing this up. Well, here's why. You know what subnetting is? Subnetting is just borrowing host bits. That's it. That's what you're going to do when you're performing subnetting. You're borrowing host bits. You always borrow host bits, and you never, ever, ever borrow network bits. Ever. I always think of an old SpongeBob routine when I hear never, ever, never, ever, never. You're always borrowing host bits. I get to say that not very often, frankly, in networking because there always seems to be an exception, but subnetting is the practice of borrowing host bits. So with all that said, and there's a lot there, so go back and watch it again if you need to, but let's go back to our practice question. You know, how many valid subnets are on the 10.0.0.0/12 network? Well, again, someone else has already done the subnetting, and we have to come up with how many valid subnets now exist. Again, I'm going to show you 2 methods for nailing these questions. They're related. But the first method is a little longer, but I want you to see exactly what's happening with subnets and where the host bit borrowing comes in because it makes it much more clear. We're not interested in just learning a fast method. We've got to learn exactly what's going on. The second is a quicker method, which I do suggest you use once you're comfortable with the first. So with all that preamble, for the longer method, we're going to do a bit-by-bit comparison of the Class A network mask, because we know 10.0.0.0 is a Class A network, and the subnet mask /12. And how do we identify the subnet bits then when the subnetting's already been done? Well, the subnet bits are going to be the bits where there's a 0 in the network mask and a 1 in the subnet mask. And that's why I'm doing this breakdown. So we've got our network mask in that top row. We know that's 255.0.0.0, and I've written it out for you here. It's nice and clean, all 1s in the first octet, all 0s for octets 2, 3, and 4. In the subnet mask, we have a /12. We know that begins with 12 1s. So that's what I've written out here. And again, our subnet bits are where the network mask has a 0 and the subnet mask has a 1. So how many do we have? We got 4, right? Because in octet 2, the first 4 bits are set to 0 in the network mask, and the first 4 bits are set to 1 in the subnet mask, and that's it. You can stop right there. So if you were writing this out in the exam room for practice, there's no real reason to write out octets 3 and 4. I just want to show you all 4 octets. But we know we've got 4 subnet bits now. So what, you ask? Well, here's why we care. Because we have to plug the number of subnet bits into this handy-dandy formula. And I hesitate to even call it a formula because that makes it sound complicated. It's not complicated at all. The number of valid subnets equals 2 to the power of the number of subnet bits. So how many subnet bits do we have? We have 4. 2 to the 4th power is the number of valid subnets. Now again, if you're not used to, or you hear 4th power or 5th power, it's like, oh, that sounds complicated. It's not. For 2 to the 4th power, all you're doing is multiplying 2 by itself 4 times. It's 2 times 2 times 2 times 2. The result is 16, because 2 times 2 is 4, 4 times 2 is 8, 8 times 2, 16. That's it. We have 16 valid subnets, and that's all there is to it. So you see where the borrowing of those host bits comes in, and to determine how many valid subnets we have, we're using this very simple calculation, formula, whatever you want to call it, and all we need to do is know how many subnet bits we have. Now, we're hitting the 10-minute mark, so I'm going to stop here, and in the next video, I'm going to show you how to solve the questions without writing the masks out, and we'll look at a different example. See you there.